Hey everybody, welcome back to the Mation YouTube channel. J.D. Teter here, Business Development Manager for Motion Control. Once again, joined by Eric Schaffer from Schaffer Engineering, joining us remotely. And this is part 4 of our Trio Motion Toolkit for LabVIEW that Eric developed and designed. Today, we're going to be looking at controlling a servo motor, including everybody's most favorite and funnest topic. If funnest isn't a word, it is today, all right? Tuning a servo motor using the LabVIEW interface. Eric, take it away, sir.
Joined by J.D. Teter from Mation. Today we're going to talk about the Trio Motion Toolkit for LabVIEW, specifically about servo control. What we're going to talk about is LabVIEW's future options using Trio controllers. We're going to look at programming using the Trio ActiveX functions and the Trio basic functions using LabVIEW. We're going to demonstrate and talk about servo control and tuning, the Trio Motion Toolkit, demo the servo, and where to find the toolkit. Okay, we're going to talk about LabVIEW's future options using Trio. The Trio Motion controllers are developed by and provided by Trio Motion Technology. They've been providing controller hardware since the 1980s, and the hardware is supported by Mation. LabVIEW Motion is PC-based and is compatible with LabVIEW through the ActiveX library. Today we're going to talk about the two options using the Trio ActiveX functions from their library. That's limited to those functions in the library. But in addition, we can use any of the Trio basic functions executed in LabVIEW. To show you about those functions, we're going to take a look at their software reference manual. Here's the Trio software reference manual, and you can see we have over 1,300 pages of functions, any of which can be run in LabVIEW. Here's examples of all of the Trio basic commands. And I'd like to talk about one specifically, which is the frame function. The frame function allows the operator to program using any of the robotic designs included in Trio. All of the calculations are done on the Trio controller, and you basically need to specify what the linkage looks like and then just give the endpoints for your function or your apparatus using LabVIEW. The Trio Motion Toolkit is an add-on toolkit that supports the Trio Motion controllers and runs multi-axis motion for both steppers and servo applications. It's a full instrument driver library with supporting examples, with future support of EtherCAT drives and motors. The toolkit was developed with NI and approved by their LabVIEW Tools network and installed using the VI Package Manager. I will now give demos of different of the servo examples. So how do we find any of these examples? We can go and look on the palette under Instrument I/O, Instrument Drivers, and then select the Trio Motion palette. As other instrument drivers, we can use the VI tree, and this gives all of the functions available to the programmer. In addition, we can look for the examples. These are the specific examples for servoing. So the first thing we're going to look at is the Jog Servo. The Jog Servo, first we set up the IP address of the Trio, and then we set up the access parameters. In addition to setting up what kind of apparatus or what kind of tool it is, or motor, this is a servo, we can set up the units, which is here, the units per rev, 25 revs per second, and acceleration at 100. We can also set up uniquely here the position loop gains, such as the proportional gain, D gain, etc., to start up the axis.
And I think a key thing here, Eric, is with these axis parameters, these actually go into your startup routine, right, into the Trio controller.
Everything here programs the Trio controller. Yes, J.D. So let's take a look. We can take a look at the servo here. We can jog forward, and we can jog reverse. In addition, we can demonstrate setting up different parameters here, such as speed. So let's say instead of 25 revs per second, we wanted to run at 50 revs per second. The other unique thing here is we can also look at the parameters, any of the parameters that are on the axis. One of the things I like to look at is the M position, which is the absolute position of the axis. The other things we can handle are the drive faults and following errors. We'll demonstrate this in a future example. So let's see what we get on the block diagram here. Uniquely on the jog routines, I provide a producer-consumer structure that you can use for this routine or any of your other LabVIEW routines. This includes all error handling as well as the producer-consumer structure. Any of these, we show the initialization, which is setting up the IP to the Trio controller and opening the controller communication. In addition, we handle all of the servo setup. From here, we can set up any of the axis parameters, such as the type, speed, accel, any of the limits, and servo enables. In addition, we can have all the gains set up for us.
So we've seen some jogging, and I think you mentioned something about doing some indexing or some other commands in the servo system.
That's right. So what we will look at next is a different example that shows some of the more functions that J.D. was talking about. So here's the motion demo servo. In this one, we can also demonstrate homing. Here we're going to do a creep reverse to the Z marker on the encoder. So let's take a look at that. Here we can look at move relative motion or a move absolute position. Again, we can take a look at the value here, see what our absolute position is. The other thing that we can take a look at here is how to do drive faults or show drive faults. All of this is explained in all the documentation on testing. So right now we have hardwired in a drive fault. Let's take a look what happens here if I set it. The error handling picks that up and tells us what actually happened and how to clear it. We can do that right from a function here, drive reset. The other thing we're going to take a look at is following error. And here, this will explain to us how we can set up a following error. So let's follow it. We're going to set up our speed to 250 revs per second, which is something the controller isn't capable of doing. We'll set a distance of 100 revs. And let's try and make that move and see what happens. Here we can see that the following error is exceeded, and this again is picked up through the error handling, and then it tells us how to clear it.
So you've got a built-in troubleshooting guide right into the interface.
That's
so you don't
right.
Need to be a servo motion expert.
That is right. The examples tell us how to do it, and we'll demonstrate actually on the block diagram how to do it. So let's take a look at the block diagram here. Again, this demonstrates the initialization and setup like we have previously. We can then see how to do homing, set up our specific homing function, relative moves, absolute moves, read and write settings, and then here we can actually shows you how to clear a following error with examples, and how to clear the drive fault.
And there's a lot of information here.
Yep. So the other thing we can show you is under all of this we have error handling, which we demonstrated before. So this VI will handle all of your errors and give you explanations for them, everything from communication, command errors, as well as hardware, software limits, drive faults, and following errors, and automatically detects them and gives you those as an error. So that's an example of running.
Yeah, that's great. That's a really complete solution that you've got there.
Mm-hmm. So let's take a look at our last thing here today, and let's show how to tune a servo.
When you say tuning, what do you really mean? What does tuning mean to a servo?
So what we're going to do here, we actually have open loop and closed loop tuning. What we're going to demonstrate here is closed loop tuning. So we're going to throw a square wave that we define into the motor, and we're going to take a look at what the actual output looks like. What is really handy is that Motion Perfect gives us an oscilloscope function that we can run interacting with our LabVIEW program. And then we can also input setting it up. So I have included with the LabVIEW folder way different tuning setups. So here we're going to use the M-Speed tune-up. This is also defined in the README file how to do this.
So you've really taken a lot of the guesswork out of this. You give the complete soft scope. You might hear that term, soft scope. You've got the whole soft scope set up here. A person doesn't really have to be an expert per se in any of this stuff.
That is right. So what we're going to do now is we've set up the scope. We're going to set up a trigger here, and that we now have a profile that's set up with a P of gain. We're going to throw a square wave in, and we're going to do this move, which is all described. How to do this, again, all the description is in the help files on how to do this tuning. So let's see what happens when we run this and see what we get on the scope. Okay, so you see we have some overshoot here. The other thing we can see is we're not exactly we're dithering a little on our stop move. So why don't we go first, and we're going to go to the I gain here. And through some experimentation, I've tuned this previously, I know 0.01 is a good value, so let's take a look what happens when we do that. See, just by doing that small tuning on the integral gain, we've pretty well cleared up the dither. So the other thing I've been working with is I know that a D gain of 2 is a better tuning for this motor. So I'm going to just try that out. I can then clear the scope, and let's try again, see what happens. And you see we have a much better profile.
Yeah, just a little bit of overshoot, but comes back and stabilizes fairly quickly.
I'm going to expand things a little to give you a better idea. I'm going to take the P gain, throw a 1.5 in, and we're going to see what happens there. See, we need to write it first. We're going to clear it, the scope. And as we expect, it's a little hot. Let's take the P gain to a 0.5 and let's see what happens there. Again, remember to reset a trigger and move. And now you can see we've softened it out. So you have some good handle on tuning your motor. So let's take a little look at the block diagram to finish up here. And right here shows how we do the trigger data collection and move. Right here, I've provided a scope function that actually interacts with the Motion Perfect to set that trigger. And first setting the parameters on our move, set up the trigger and distance, and when we make the move, that trigger then will show up on the Motion Perfect oscilloscope. That pretty well covers what we want to talk about today on the servo motion.
That was awesome, Eric. Where can customers find the Trio Motion Toolkit in the LabVIEW environment?
That's a great question, J.D. Here's where you find the Trio Motion Toolkit. Go to any of your LabVIEW programs and under the Tools pull-down, go to Find LabVIEW Add-ons. That'll bring you directly to the Trio Motion Toolkit under the NI Tools network. There, type in Trio, select Trio Motion Toolkit, and you will then be able to load it from the Trio Motion Toolkit screen and purchase it directly from NI. If there are any questions, please contact me or J.D. Teter at PowerMation, or Stephen Leeds at PowerMation, or Ed Novak at Trio Motion Technology.
Thanks everyone for watching video number 4 of the Trio Motion Toolkit for LabVIEW. To recap this series, we had video 1, Intro to the Toolkit, video 2, an overview of the Trio basic commands, video 3 was the multi-axis control, video 4 was servo control and tuning. So thanks Eric for taking the time to run us through your new toolkit. None of this would have been possible without the exceptional support from our Trio Motion team, with a special shout out to Ed Novak, who provided the motion coordinator that is being used in these videos. If you have any questions on the Trio controller, feel free to contact myself, Ed Novak, or your local PowerMation sales rep. For questions on the Trio Motion Toolkit itself, contact Eric directly. Look for future videos on the Trio Motion Toolkit where we'll be using the Trio Motion Coordinator to demonstrate an EtherCAT-based motion system. As always, if you like what you see, hit that like and subscribe button down below to see more content on the PowerMation YouTube channel. Thanks again. Have a great day.